Alright, welcome. This is the video for Part B of the summer packet, and Part B asks you a little bit about domain and range for some functions. Okay, just a couple reminders about definitions. I really shouldn't have to be reminding you of these definitions because you've pretty much seen them every year in your high school career. But, for the heck of it, let's do it again. The domain for a function is all the possible x values that function can take, so all of your inputs. The range of any function would then be all of the corresponding y values or outputs of a function. Now, the important thing that's in the directions for this packet that I really want you to start getting the hang of using, because it's going to make life a lot easier when we get into calculus next year, is I want you to give me the answers in interval notation, and that's how I will be doing these problems in the video as well. Just a quick reminder about interval notation. So I know in Algebra 2 we did that thing called set builder notation, the set of all x such that, and then we had a condition. To make it a little bit easier to read and understand, we can also think of a set just in terms of an interval. You know, a beginning point, an end point, and all the numbers in between. The big idea with an interval, though, is understanding whether it's an open or a closed interval. So remember, if you have brackets around either endpoint, that means it's closed, which means it includes whatever endpoint has a bracket around it. If you have parentheses around either endpoint, then it's an open endpoint, which means it's everything except that value. We don't include the endpoint. It's very similar to when you use inequalities, whether or not you have the equal bar underneath a less than or greater than sign. All right? I think it's much easier to work with when you have interval notation as opposed to set builder notation. So let's do some examples of some functions, and let's talk about what their domains and ranges would look like. So here's the first one. Let's use a polynomial. Let's use a nice basic quadratic. F of x equals negative x squared plus 6. Okay, so when I think about domains and ranges, especially for a polynomial function like this, what I'd probably want to do is, in my head, think about what the graph might look like. All right, and since you can't really get inside my head in a video, I'm going to do a little sketch. So it's negative x squared, so I know it's going to be a parabola that points down. The plus 6 means instead of starting at the origin, it's going to start up here at positive 6. So that's going to kind of be the rough sketch of my graph. So looking at that graph, we think about what values can x take? What can I plug in for x? Well, since the graph keeps going on either side of the x-axis, right? I mean, I know it cuts off here, but that's just because it's a small picture. I don't think there's a value of x I can't use. So my domain is all reals. So using interval notation, what we would write is we would have the open interval from minus infinity to positive infinity. And that's just a simple way to say x is all real numbers. Okay, it's everything from negative infinity to positive infinity. The reason why it's open and not closed for an infinite endpoint is because, remember, infinity is not a number, it's a concept. So you can't include it because it's not a numeric value. So anytime you see an infinity in a domain or a range, you must use an open endpoint for that. Okay? Now let's look at the range. Since I know that this graph has a maximum value at 6, and the arrows mean it's going to keep going down the negative y-axis, we're basically saying that 6 is the highest point that the graph can be, and the lowest point would be negative infinity. So, our range would start at negative infinity, and it would get bigger and bigger until it gets to 6, and then it would stop. But now notice I have a right bracket around the 6 because it does include 6. When x is 0, f of 0 is 6, so 6 is in my range. Okay, so that's what I'm looking for domain and range in this section. Let's try another one. Let's do f of x equals the square root of x plus 2. All right, I am not going to draw this one out because really at this point, these basic functions, you should have some idea what domains and ranges are for basic functions because you've been studying them a lot over the last couple years. Now for domain, it's a square root. So whatever's inside that square root has to be positive. So that's how I figure out how to restrict my domain. I say, all right, well, x plus 2 has to be positive. So x has to be bigger than negative 2. Anything less than negative 2, and I'm going to have a non-real function value, and we only deal with functions that are defined in the real numbers. We're not going to deal with imaginaries. So my domain has to be everything larger than negative 2. Actually, excuse me, it's x plus 2 can also equal 0. So actually, our endpoint will be closed here. X can equal negative 2. But that is going to be my endpoint. and it can go all the way out to positive infinity. So everything from -2 inclusive out to infinity will be legal inputs for that function. Now for the range, do we remember how square root functions are graphed? Again, you should be doing these in your head, but the square root of x plus 2 is going to look a little something like this along the first quadrant. So if you notice, the graph only stays put in the first quadrant. So that means my y's are only going to be positive real numbers. So we're going to go from 0, again that should be inclusive, because when x is -2, y does equal 0, out to positive infinity. Okay? So this is just another way of saying the range is the set of all y's such that y is greater than or equal to 0. I just like this better. You're going to see it written this way in your Calc book. You're going to see it written this way on the Calc exam. So I want to see you get used to writing it and understanding what it means. Let's just do a couple more. So let's look at a trig function. Again, you shouldn't have to do any graphing of this because you really should know what's going on for a trig function's domain and range at this point. If not, you need to be good with this stuff before you enter class in September. So here's a trig function. G of x equals 4 cos 3x. Okay, so cosine functions are very well defined. They're those nice periodic oscillating waves. I don't think we're going to have any issues with domain. I can put anything I want in the x. Don't let the 3 fool you. All the 3 means is the period is going to be different. It's not going to be at 2 pi anymore. All right, but it's still going to have that same shape as cosine of just plain x. So it's going to have the same domain as that, and that's all reals. So when we deal with all reals, we're saying from negative infinity to positive infinity inclusive, like we did with the quadratic in the last slide. Now my range, remember what the 4 means in front of a trig function, or any number for that matter in front of a trig function. That's your amplitude. So that means this curve and this wave is only going to get as high as positive 4 and as low as negative 4. So the range will be the closed interval from -4 to positive 4, because it's just going to oscillate from those two max and min values. Let's do one more. Let's do a rational function, okay? Let's do h of x equals 2 over x plus 4. Now, if you remember how rational functions are graphed and behaved, that's the ones where you have to worry about asymptotes. More on that later on in this video series because you're going to deal with asymptotes later on in the packet. For starters, though, let's just think about where the function is non-defined. Okay, it's a rational function. Rational means like division. It's like saying 2 divided by x plus 4. Well, we can't divide by 0, so x plus 4 cannot equal 0. So that means, basically, I can put anything I want except -4 into this function. So that's going to be the restriction of my domain. Now, it's all real numbers except the value -4. When we go to write this in interval notation, there's actually 2 intervals we're going to write. So there's a little set theory involved here. So we're going to start at negative infinity. We're going to stop at -4. This is going to be double open because x cannot equal -4. It's just going to get very close to it on either side. Okay, so that gets all the negative values. That gets everything less than -4. We also have to get the positive things, the things to the right of -4. So we've got to write a second open interval from -4 to positive infinity. And then we're going to write this U thing. This letter looks like a letter U. It's actually a symbol. The symbol is for the command union. Okay, that means it's both this interval and that interval. All numbers in either of the intervals. It's basically like adding 2 sets. Okay? Now my range, if you were to look at a sketch of this graph, you have a asymptote, a vertical asymptote at x equals -4. One side of the graph will go up towards positive infinity. The other side will go down towards negative infinity. So I think our range is going to end up being all real numbers. So we'll just use our negative infinity to positive infinity, okay? Very important concept. I know this was a little bit of a lengthier video, but it's very important that you understand both how to compute domains and ranges for some basic functions, as well as how to write them and read them in interval notation. Okay? Thank you for watching.